Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll walk you through the fundamentals of Amazon EBS, what it is, how it integrates with Amazon EC2, and why it plays such a critical role in AWS architecture. You'll learn how EBS provides block-level storage that is both scalable and persistent, making it ideal for workloads that require consistent performance and data durability. Let's get started. Amazon Elastic Block Store (EBS) is a high-performance, durable block storage service designed specifically for use with Amazon EC2. It offers persistent storage that continues to exist independently, even if an EC2 instance is stopped or terminated. With the ability to scale from a few gigabytes to multiple petabytes, EBS provides flexible and reliable storage for a wide range of workloads, including operating systems, applications, and databases. There are multiple types of EBS volumes to choose from, based on your workload needs. SSD-backed options like general purpose, GP3, and provisioned IOPS, IO1, IO2, are ideal for transactional workloads that demand fast I/O performance. HDD-backed volumes, such as throughput-optimized ST1 and cold HDD SC1, cater to large sequential workloads like big data and log processing. EBS volumes are built for high availability, with data automatically replicated within the same availability zone to protect against hardware failures. You can create point-in-time snapshots of volumes for backup and disaster recovery, and these snapshots are stored in Amazon S3 for added durability and cross-region support. To enhance security, EBS supports encryption at rest and in transit, seamlessly integrating with AWS Key Management Service, KMS. With its performance, scalability, and enterprise-grade reliability, EBS is a critical component in building robust applications on AWS. This illustration represents the Amazon Block Storage ecosystem within AWS, breaking down the key options available for Elastic Block Store, EBS, EC2 Instance Store storage types. At the top, you see EC2 Instance Store, which provides temporary block-level storage directly attached to an EC2 instance. This high-speed storage can be either SSD or HDD-based, but it is ephemeral, meaning the data is lost when the instance stops or terminates. It's ideal for caching, scratch data, or temporary workloads. The middle path highlights EBS SSD-backed volumes, which offer persistent block storage. These volumes come in two types: general purpose, GP3, GP2, balanced for price and performance, suitable for most workloads like boot volumes, small to medium databases, and dev test environments. Provisioned IOPS, IO2, IO1, designed for I/O-intensive applications like large databases that require high throughput and low latency. The bottom tier showcases EBS HDD-backed volumes, optimized for high-throughput workloads with large sequential data access patterns. ST1, throughput-optimized HDD, ideal for big data, data warehouses, and log processing. SC1, cold HDD, cost-effective for infrequent access to data, such as backups or older logs. This layered architecture allows AWS users to select the most suitable block storage option based on performance, durability, and cost requirements, ensuring optimal infrastructure design for diverse use cases. An instance store provides temporary block-level storage for your EC2 instance. This storage is provided by disks that are physically attached to the host computer. Instance store is ideal for temporary storage of information that changes frequently, such as buffers, caches, scratch data, and other temporary content. An instance store consists of one or more instance store volumes exposed as block devices. The size of an instance store, as well as the number of devices available, varies by instance type and instance size. Not every EC2 instance type provides instance store volumes. Instance store volumes are attached only at instance launch. You can't attach instance store volumes after launch. You can't detach an instance store volume from one instance and attach it to a different instance. An instance store volume exists only during the lifetime of the instance to which it is attached. You can't configure an instance store volume to persist beyond the lifetime of its associated instance. The data on an instance store volume persists even if the instance is rebooted. However, the data does not persist if the instance is stopped, hibernated, or terminated. When the instance is stopped, hibernated, or terminated, every block of the instance store volume is cryptographically erased. Therefore, Do not rely on instant store volumes for valuable long-term data. Amazon EBS provides persistent, block-level storage volumes that function just like traditional hard drives, but with the flexibility and scalability of the cloud. When you attach an EBS volume to an Amazon EC2 instance, it behaves like a physical disk, ready for formatting, mounting, and storing data. This makes EBS volumes ideal for workloads that require frequent updates and high availability, such as operating systems, databases, or applications that perform real-time analytics. One of the key benefits of EBS is its flexibility. For current generation EC2 instances and volume types, you can dynamically resize volumes, adjust provisioned IOPS for performance tuning, and even change the volume type, all without detaching the volume or interrupting your applications. This allows you to fine-tune performance and cost as your needs evolve, even in live production environments. EBS volumes are designed for durability and data persistence. Unlike instant store volumes, data on EBS volumes remains intact, even if the associated instance is stopped or terminated. This makes them perfect for storing mission-critical data. You can also attach multiple EBS volumes to a single instance to organize data across different drives, or to increase storage capacity. Volumes and instances must reside in the same availability zone for attachment, ensuring low latency communication. For specific use cases such as clustered applications, EBS multi-attach allows a single volume to be attached to multiple instances simultaneously, enabling shared access and increased redundancy. Overall, EBS offers a powerful, reliable, and flexible storage solution that integrates seamlessly into a wide variety of AWS workloads. Let's take a quick look at some of the key features and benefits that make Amazon EBS a go-to choice for persistent block storage in the cloud. Data availability. When you create an EBS volume, it is automatically replicated within its availability zone to prevent data loss due to failure of any single hardware component. If you attach multiple volumes to a device that you have named, you can stripe data across the volumes for increased I/O and throughput performance. Data persistence. An EBS volume is off-instance storage that can persist independently from the life of an instance. You continue to pay for the volume usage as long as the data persists. EBS volumes that are attached to a running instance can automatically detach from the instance with their data intact when the instance is terminated, if you uncheck the Delete on Termination checkbox when you configure EBS volumes for your instance on the EC2 console. The volume can then be reattached to a new instance, enabling quick recovery. Data encryption. For simplified data encryption, you can create encrypted EBS volumes with the Amazon EBS encryption feature. All EBS volume types support encryption. You can use encrypted EBS volumes to meet a wide range of data-at-rest encryption requirements for regulated audited data and applications. Amazon EBS encryption uses 256-bit Advanced Encryption Standard Algorithms, AES 256, and an Amazon Managed Key infrastructure. The encryption occurs on the server that hosts the EC2 instance, providing encryption of data in transit from the EC2 instance to Amazon EBS storage. Data security. Amazon EBS volumes are presented to you as raw, unformatted block devices. These devices are logical devices that are created on the EBS infrastructure, and the Amazon EBS service ensures that the devices are logically empty. That is, the raw blocks are zeroed or they contain cryptographically pseudo-random data, prior to any use or reuse by a customer. Data backups. Amazon EBS provides the ability to create snapshots, backups, of any EBS volume, and write a copy of the data in the volume to Amazon S3, where it is stored redundantly in multiple availability zones. The volume does not need to be attached to a running instance in order to take a snapshot. As you continue to write data to a volume, you can periodically create a snapshot of the volume to use as a baseline for new volumes. These snapshots can be used to create multiple new EBS volumes or move volumes across availability zones. Snapshots of encrypted EBS volumes are automatically encrypted. Amazon EBS offers two general-purpose SSD volume types, GP3 and GP2, both designed to deliver a balance of price and performance for a broad range of workloads. The GP2 volume type is the legacy general-purpose SSD offering. It delivers performance based on the size of the volume, with baseline performance starting at 3 IOPS per GB and the ability to burst up to 3,000 IOPS for volumes smaller than 1 terabytes. This makes GP2 well suited for boot volumes, small to medium-sized databases, and development test environments. GP3, the newer generation, improves upon GP2 by providing predictable performance regardless of volume size. With GP3, you get a baseline of 3,000 IOPS and 125 megaparsec throughput by default, and you can independently provision up to 16,000 IOPS and 1,000 megabytes per second, all without having to increase the volume size. This decoupling of performance from capacity offers significantly more flexibility and cost efficiency. In fact, GP3 is generally 20% cheaper than GP2, while delivering higher baseline performance. Both GP2 and GP3 volumes are designed for durability and low latency, and they integrate seamlessly with EC2, making them ideal choices for general-purpose workloads like boot volumes, application servers, and medium-sized databases. The IO1 volume type in Amazon EBS is designed for I/O-intensive applications that require high performance and consistent low latency storage. It is a solid-state drive, SSD-backed option that allows you to provision a specific number of IOPS, input-output operations per second, making it ideal for critical workloads where performance consistency is key. With IO1, you can provision up to 64,000 IOPS per volume when attached to Nitro-based EC2 instances. This makes it well suited for large relational or NoSQL databases, transaction-intensive applications, workloads that require high IOPS and throughput. Key features of IO1 volumes include provisioned IOPS. You can define the exact performance you need, up to 50 IOPS per GB, which is higher than general-purpose volumes. High durability. IO1 volumes offer 99.8% to 99.9% durability, minimizing the risk of data loss. Multi-attach. IO1 supports simultaneous attachment to multiple EC2 instances within the same availability zone, enabling high availability setups for clustered applications. The IO2 Block Express volume type is Amazon EBS's highest performing SSD offering, designed for mission-critical applications that demand ultra-high IOPS, low latency, and high throughput, all at enterprise-grade durability. With IO2 Block Express, you get performance scaling well beyond the limits of traditional IO1 and IO2 volumes. A single volume can deliver up to 256,000 IOPS, up to 4,000 megabytes per second throughput, sub-millisecond latency, 99.999% durability. That's 1 in 100,000 annual failure rate. This makes it ideal for I/O-intensive workloads, such as large-scale high-performance databases like Oracle, SAP HANA SQL Server, real-time analytics engines, and high-throughput transactional systems that cannot afford performance degradation or data loss. Block Express leverages a scalable and distributed architecture, similar to that used in high-end SANs, storage area networks, offering consistent performance at scale. It also supports multi-attach, allowing the same volume to be simultaneously connected to multiple instances for high availability and failover scenarios. While IO1 is slightly older compared to its more powerful sibling, IO2, it remains a popular choice for applications that need predictable and high IOPS performance, but don't require the extreme durability or performance ceiling of IO2 Block Express. The ST1 volume type in Amazon EBS stands for Throughput Optimized HDD. It is a low-cost magnetic hard disk drive HDD-backed storage option designed for high-throughput sequential workloads. ST1 volumes are ideal for applications that require frequent large and sequential I/O operations, such as big data analytics, data warehouses, log processing, streaming workloads. Unlike SSD-based volumes, which are optimized for IOPS, ST1 is optimized for throughput, measured in MB per sec rather than IOPS. It provides baseline throughput with bursting capabilities, allowing volumes to temporarily deliver higher throughput when needed. ST1 volume type offers a budget-friendly option for large-scale storage needs, making it ideal for applications such as big data, log processing, and data warehousing. Each volume delivers a baseline performance of up to 500 MB per second, with burst capabilities that scale with volume size. However, ST1 is optimized for large block sizes and sequential I/O patterns, and is not well suited for small transactional workloads like databases, where low latency and high IOPS are critical. ST1 volumes provide an economical solution for workloads that need high throughput over high IOPS, making them perfect for scanning and processing large volumes of data efficiently. The SC1 volume type in Amazon EBS stands for Cold HDD hard disk drive and is designed for infrequently accessed throughput-oriented workloads. It offers the lowest cost per GB among all EBS volume types, making it ideal for scenarios where storage cost is more important than performance. SC1 volumes are best suited for cold data storage, backup repositories, archive logs, older and less frequently accessed datasets. These volumes are optimized for sequential read-write operations, just like S1, but at a lower baseline throughput. They offer baseline throughput of up to 250 MB per second, with burst capability depending on the volume size and burst credits. The S1 volume type, or cold HDD, is the most cost-effective Amazon EBS storage option, making it ideal for storing large volumes of data that are accessed infrequently. It is best used for workloads where performance is not a primary concern, such as backups, archives, or older logs. SC1 volumes are engineered for large block sizes and sequential access patterns, but they are not well suited for latency-sensitive or transactional workloads that require consistent and fast input-output operations. Random read-write performance is limited, so it's important to match SC1 volumes with the appropriate use cases to maximize their value. SC1 volumes offer a cost-effective option for storing large amounts of data that don't require frequent or fast access, making them a smart choice for long-term retention and archival storage in the cloud. Amazon EBS snapshots allow you to back up the data on your EBS volumes by creating point-in-time copies of the volume's data. These snapshots serve as a reliable backup mechanism, enabling disaster recovery and data protection for your EC2-based applications. EBS snapshots are incremental by design. Only the data blocks that have changed since the last snapshot are saved. This greatly improves storage efficiency and reduces backup times and costs. Even though the snapshots are stored in Amazon S3, they are not directly accessible from S3. Instead, they are managed entirely through the EBS and EC2 APIs. Once created, snapshot data is automatically replicated across all availability zones (AZs) within the same region. This built-in replication ensures high availability and durability of the snapshot data, restoration flexibility, as you can recreate a new EBS volume from the snapshot in any AZ within the region. When you restore a volume from a snapshot, it starts as an exact replica of the original volume at the time the snapshot was taken. Over time, the new volume lazily loads blocks as they are accessed, which means your applications can start using the volume immediately, even if all the data hasn't been loaded yet. EBS snapshots offer a powerful, cost-effective, and regionally resilient method to safeguard your persistent storage in AWS. The snapshot lifecycle begins when you initiate the creation of an Amazon EBS snapshot for an existing volume. This action captures a point-in-time backup of the data currently on that volume. The process is particularly useful for backing up critical data, protecting against accidental deletion or failure, and enabling replication across environments. Importantly, snapshot creation is an asynchronous process. This means that while the snapshot is initiated and appears in your AWS console right away, it doesn't immediately contain all the necessary data. Initially, it enters a pending state, during which AWS begins copying the data blocks from the EBS volume to Amazon S3, where all snapshots are stored behind the scenes. The time it takes to complete this transfer, and thus for the snapshot to move from pending to completed, depends on the amount of data that has changed since the last snapshot. Because EBS snapshots are incremental, only modified blocks are copied during this process, making subsequent snapshots faster and more storage efficient than the initial one. Once a snapshot has been successfully created and reaches the completed state, it becomes fully available for use, including the ability to copy it. A snapshot copy is a duplicate of the original, containing the same data as the source at the time of creation. However, this new copy is assigned a unique resource ID, allowing it to be managed independently from the original snapshot. You can copy any snapshot you own, as well as snapshots that have been shared with you, and whether they are shared privately by specific AWS accounts or made publicly available. This functionality is especially useful for creating backups in different regions for disaster recovery or for sharing configurations across multiple environments or teams while retaining control over your own copy. You can create a new Amazon EBS volume from an existing snapshot, effectively restoring the data to a usable state. The newly created volume starts as an exact replica of the original volume at the time the snapshot was taken, including all data, file system structure, and configurations. This allows you to quickly recover from data loss, migrate workloads, or replicate environments for testing or scaling. Since the volume is restored from a snapshot, you can create it in any availability zone within the same region, giving you flexibility in deployment. Once the volume is created, it can be attached to an EC2 instance and used just like any other EBS volume. Amazon EBS Snapshots Archive is designed for cost-effective, long-term retention of infrequently accessed EBS snapshots, ideal for compliance, audit, or backup retention policies. When you move a snapshot to the archive tier, it's automatically converted into a full snapshot, independent of previous snapshots, which simplifies long-term storage and retrieval. The archived snapshot is stored in a lower-cost storage class, significantly reducing your ongoing storage costs for data that doesn't require frequent or immediate access. If you need to access an archived snapshot, you can restore it back to the standard tier, a process that typically takes up to 72 hours. Once restored, it behaves like any other snapshot in your account, and you can use it to create new volumes or copy it across regions. When an Amazon EBS snapshot is no longer needed, you can safely delete it without affecting the EBS volume from which it was created. Similarly, deleting the volume has no impact on any existing snapshots, as snapshots are independent backups. To protect against accidental deletions, AWS offers Recycle Bin, a recovery feature that allows you to retain deleted EBS snapshots for a configurable retention period. During this time, you can restore snapshots that were mistakenly removed. If the snapshot is not restored within the retention window, it is permanently deleted and cannot be recovered. Recycle Bin provides an added layer of protection for critical data and helps ensure compliance with backup retention policies. Amazon EBS allows you to copy snapshots across AWS regions within the same account, providing flexibility for global operations and disaster preparedness. When you copy a snapshot to another region, the copy acts as a standalone snapshot in the destination region and gets a unique snapshot ID. Once the copy is complete, you can use it to create new EBS volumes in the target region, just like any other snapshot. This capability is particularly useful in scenarios such as geographic expansion, deploying your application infrastructure closer to end users in other regions for lower latency and better performance. Migration, moving workloads to a different region for cost optimization, regulatory compliance, or performance reasons. Disaster recovery, maintaining backup snapshots in a separate region ensures you can quickly restore operations if the original region experiences an outage. By enabling regional snapshot copies, AWS enhances both the resilience and portability of your cloud infrastructure. Amazon EBS also supports cross-account snapshot sharing, allowing you to share snapshots between different AWS accounts. This is particularly useful in multi-account architectures, where development, testing, and production environments are isolated into separate accounts. To share a snapshot, you begin by modifying the snapshot's permissions and explicitly granting access to one or more target AWS account IDs. Once shared, the snapshot becomes visible in the target account, though it remains stored in the original region and under the ownership of the source account. In the target account, users can create a new EBS volume from the shared snapshot, just like they would with a snapshot they own. This facilitates seamless data sharing, environment replication, or collaborative development across account boundaries, all while maintaining control and auditability through AWS Identity and Access Management, IAM, and resource policies. Amazon Data Lifecycle Manager, DLM, provides a powerful and automated way to manage the backup lifecycle of your EBS volumes. It allows you to define policies that govern the creation, retention, and deletion of EBS snapshots, helping you protect valuable data through regular backups, retain those backups to meet audit or compliance requirements, and reduce storage costs by removing outdated snapshots. With DLM, you can create policies that align with your specific backup needs. Amazon offers both default and custom policy options. Default policies are designed to simplify protection by automatically backing up all volumes and instances in a region that do not already have recent backups, while still allowing you to exclude specific resources based on exclusion parameters. For more control, custom policies allow you to target specific volumes or instances using tags and include advanced capabilities such as fast snapshot restore, snapshot archiving, cross-account snapshot copying, and the execution of pre- and postscripts. A custom policy can support up to 4 different schedules, each with its own backup frequency, retention duration, and feature configurations. This flexibility ensures that backups are not only automated, but also tailored to the operational and compliance requirements of your environment. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.